Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to the presentation of signals and systems. Now we're in chapter number 1 and we're reaching to signals decomposition. Any signal is combined of two parts. One part is even and one part is odd. Even if it is not even or odd, it could be written in a combination of two even odd signals. So basically, we're trying to visualize all the signals around us into these two basic components. Signal decomposition, we are decomposing the signals into the two parts, even part and odd part, or even component and odd component. So remember that this is the even function and this is the odd function. So what if x is neither even or odd? Still, we can write it in function of these two components. So like if we do have this signal, which is like part of it is odd and another part is even. So if we look at this signal, so let's consider this signal and we can easily figure out that this part is odd. So this is the x odd part of t, and this is the x even part of t. If we sum up these two, we will get to the x of t. So now we can write that x of t will be equal to x odd of t plus x even of t. Now x of t can then be expressed as a sum of even and odd signal components. And how this is done, as we can see from this expression, is x of t will be composed of the even part and odd part of the signal. And this is the even component, and this is the odd component of x. And to be able to calculate these two components, we could use this expressions. So if we want to find what is the even part of the x of t, so we will find x of t and we will add to it x of minus t, and then after summing both these signals together, we will multiply by half. And again here, for odd, we will find x of t and again x of minus t, but we will subtract them from each other. So just take care about this minus sign. Then we will multiply the entire summation or subtraction by half. And then we will get the odd part of the signal. So if we are interested to see an example, so let's say that x of n equals to 1 whenever n is greater than 0 and equals to 0 whenever n is less than 0. What is this? This is nothing but the definition of u of n. So this is the step function, unit step function. So this is u of n. It will be 0 everywhere, and once in negative side, and it will be equals to 1 in the positive side of n axis. So let's apply the rules that we have seen in the previous slide. So if I want to calculate the even part of x of n, or we can write it in another notation like even part of n, both has the same meaning, we have to calculate x of minus n first. Then we add both together and multiply by half. If we consider x of minus n, then we will flip the positive with the negative. So we will have at 0, we will have 1. At 1, it will be 0, 0. And from the other side, this will be 1, 1, etc. So this is 1, 2, and this is 0, minus 1, minus 2. So this is x of minus n. If we try to add these two together, we will find that at minus 2, this will be equal to 1, and this will be equal to 0. So the summation would be equal to 1. 1 plus 0 will be 1 again, but at 0 point, this will be equal to 1, and this will be equal to 1. So we will get 2. So the sequence x of n will be at even part, it will be equal to half, then this sequence will be from minus 70, then we will get 1, 1, 1, all the way till we get to the 0 point. So this is the 0 point, then it will come back again 1, 1, 1, and all the way till infinity. So if we multiply half into this, then we will get in the negative part and positive part, it will be equal to half. And at x equal to 0, it will be equal to 1. And this is shown in this figure. From the old perspective, we have calculated this, but we have to subtract u of n minus x of minus n. And then if we try to do this, which is odd, then we will have the multiplication of half into the sequence. So this will be at the negative side because this is minus this. So it will be minus 1, minus 1, all the way till we reach to this point, which is plus 1, minus 1, it will be equal to 0. And then it will be equal to 1, which is this one, plus zeros, 1 all the way. And here is the point of n equal to 0. And if we multiply this by half, then we will get minus half from this side and plus half from this side and 0 at 0 point, which will be shown here. And this would be nothing but the x odd of n as another way of notation how we write the signal. And this would be the result. So this is an example of discrete time signals and how we calculate the even part and the odd part the signal. I will leave these two examples for you to practice outside the lecture, and we will see how things are going. This is with a graphical representation, and this is with expressions representations, and let us see your results. Thank you for listening, and see you in the next